Okay, so I've gone ahead and I've estimated what the height of each one of these rectangles is. And I want to emphasize to you that making the width of each one of the rectangles equal to 1 second, that was my choice. And we could have made them smaller or larger. But the big idea is that now that we know this, I can say that the distance that I traveled on that first interval is equal to our estimate of 2.2 meters per second as the velocity times 1 second. And then I can just add up all the others. One thing that I'd like to emphasize to you is that this is not an exact science. And so one of the things that can be kind of frustrating is that if you were to do this problem entirely on your own, you would probably come up with slightly different numbers for these heights, which means that you would have a slightly different sum. When I sum all of these up, I get 25.6 meters. And so the moral of the story is that it's okay that we're not all getting the exact same answer. All right, so now let's generalize this. I want to give you a definition for something called the definite integral. And it would be helpful if first we were to look at a picture. So imagine that you've got a starting time, let's call that starting time A, and an ending time, let's call that ending time B. And then you've got this function, and this function is not sitting still. It's going up and it's going down, and maybe it's even going back up. The definite integral is a way of calculating a product, and that product is going to be the product of f of x and the change from A to B. Now the change from A to B is given by B minus A. So when we say that the definite integral